Today we are talking about 6.3 bisectors in triangles, and this will relate to Chapter 5, Lesson 2 in your whole textbook, called Bisectors in Triangles. So again, the first things that you should look at are the theorems. We are going to discuss the circumcenter and the incenter of a triangle. So what's important to note is the difference between the two. The circumcenter, as I've noted down here, comes from or is generated from perpendicular bisectors. So remember, those are a perpendicular line to each side of your triangle that bisects it, cuts it in half. So BC is bisected by this red line here. AB is bisected by its red perpendicular there, and AC is bisected. So what happens is when you have those three perpendicular bisects, they will meet at a point in the triangle called P, called the circumcenter. The other thing that is nice is when you find the circumcenter point P, you have those three perpendicular bisectors, but then the distance, the blue lines here, to each of the vertices. So each of the corners or each of the angles of this triangle are congruent. So each of these blue lines here in this first theorem are congruent. So PB is the same length as PC, which is the same as PA. So if the perpendicular bisectors come together at a point P, then that point to the vertices, so that point to the angles are congruent. On the other side of things, we can talk about angle bisectors. So this is where we are dividing an angle in half as opposed to a side. So when you have your angle bisectors, so again, those are the red lines in the second triangle here, they come together at a point. That's called the incenter. So the incenter is where angle bisectors meet. Circumcenter is where perpendicular bisectors meet. Okay. So again, in the second theorem, we have the red lines, which are angle bisectors, coming together at point P. And once you find that incenter, the nice thing about that is that the distance then to the sides this time are all the same. So again, these blue lines here that I'm highlighting in red, those become the same. So from P to Z is the same as P to Y, which is the same as P to X. So if angle bisectors converge, it's all the same distance to the sides. And if perpendicular bisectors converge, that is all the same distance to the angles. So try and keep these definitions and these key terms separate in your mind. So again, we're talking about the circumcenter in this example. So point O is the circumcenter, which means it is the spot that all of these perpendicular bisectors came together. So remember, these are perpendicular bisectors, which means point B right here is right in the middle of X and Z. Point A is right in the middle of Y and Z, and point C is right in the middle of X and Y. So we're told that ZA, so this distance right here, is equal to 5. We are told that XC, which is this distance here, is equal to 2.3. And we are told that OY, so the distance from O to Y right here in red, is 7.4. So that is from the circumcenter out to a vertex. We are asked to find AY. Well, remember, ZY is bisected by A, so if ZA is 5, AY is also 5. That's what those two little red marks mean inside the triangle. We're asked to find XY. Well, again, remember that XY is bisected. So if one half is 2.3, the other half is 2.3, which means the entire distance is 4.6. Now, if you recall from the circumcenter theorem, when these perpendicular bisectors come together, this point O is the same distance to each of the angles here. So O to Y, which is 7.4, is the same as O to Z. So OZ is 7.4, and it's also the same distance from O to X, that other angle. So OX is 7.4 as well. So what's important in these pictures is to tell yourself or ask yourself, what am I given? You're given perpendicular bisectors. So that means from that O, that circumcenter, out to each of the vertices, you are all the same distance. Now, you can also find the circumcenter. So say you're given 3 points, and we're going to be given points A, B, and C. So what we're going to do is we're going to graph them. And we're going to have to count by 2. So 2, 4, 6. Here is -7, 0. So this is point A. B is 0, 0. And C is 0, negative 10. So 2, 4, 6, 8, 10. So this is point C right here. So you know it's a triangle, so you can connect your dots and actually sketch the triangle. Now what we're wanting to find is the circumcenter. So we just need to find two perpendicular lines and see where they intersect. Now if this was not a horizontal and a vertical line, all you would have to do is just like in the last lesson when we found the equation of a perpendicular bisector, you would just do that same process twice and then determine where they intersect. For this one, it's a little easier because we actually have AB is a horizontal line. So we just need to find the midpoint of AB. So between A and B, so we'll say the midpoint of AB. And if you think about it, it goes from 0 to negative 7, so that we know we're going to be halfway between 0 and negative 7, which is negative 3.5. But to practice our formula, what we're going to do is we have a point where we add up our x's, so 7 and 0, and divide by 2. And then we add up our y's, 0 plus 0, and divide by 2. So that means that the midpoint of segment AB, this horizontal segment right here, is going to be negative 3.5, 0. So negative 2 and 3.5 is right about right there. So that's negative 3.5, 0. Likewise, let's work with segment BC because that's a vertical line. So again, when you have horizontal and vertical lines, it's much easier to find the perpendiculars because it just goes the opposite way. If it's horizontal, the perpendicular is vertical. If your side is vertical, the perpendicular is horizontal. So the midpoint of BC, so B to C, we're going to add up our x values, divide by 2. We're going to add up our y values, 0 plus negative 10, and divide by 2. So again, when you simplify, you get 0 and then negative 5, which makes sense because if you're going halfway between B and C, it would be along the y-axis here and at negative 5, which is right here. This is negative 5, or I'm sorry, this is 0, negative 5. My apologies. Okay, so now if we're trying to find a perpendicular at these points, we want to think about what would the equation of a perpendicular line, a vertical perpendicular line be. So the perpendicular right here would be an x equals, because we want the equation of a vertical line, so x equals, and then whatever it has to cross through, negative 3.5. To determine the equation of the perpendicular to this vertical line right here, this is going to be a horizontal line. So again, the equation of horizontal lines are y equals whatever y value we need to cross through, which is negative 5. So if we're curious about what point they cross at, well, we only have one x value and we only have one y value. So the point that these two intersect would be negative 3.5, negative 5. And so because that's where perpendicular bisectors, because they're bisectors because we found the midpoints, point where they intersect, that is the circumcenter. That is the circumcenter. Switching gears here, let's look at angle bisectors. So this PI, QI, and RI are each an angle bisector. You can tell by these little red markers. 1 and 1 means angle P is cut in half. 2 arcs and 2 arcs means angle R is cut in half. And 3 arcs and 3 arcs means angle Q is cut in half. So we have 3 angle bisectors that come together at the point I, which is called the incenter. So the measure of angle Q, so this whole angle is 70 degrees. The distance from I to the side PQ, so this distance here is 3.5. Now keep in mind, the incenter, it is formed by the 3 angle bisectors, but what's important is that that spot at I is the same distance from all of the sides. So however far I is from PQ, it's the same distance to PR, and it's the same distance to QR. So these 3 little distances here are all the same. So we want to find the measure of IPQ. That's going to be this little angle here. Well, remember, Angle P is bisected, so half of it would be half of 70, which is 35 degrees. The distance from I to QR, so from I to this side, and from I to PR, they're all the same, so they both must be 3.5 because I is the incenter. So please let me know if you guys need any